video, I will present about what is concrete, type of concrete, and concrete type. What is concrete? Concrete is a building material made by mixing cement, water, sand, and gravel. There are 6 types of concrete. There is high strength concrete, high performance concrete, reinforced cement concrete, plain cement concrete, ready-mix concrete, and self-compacting concrete. Concrete test that I choose is concrete slump test. Now I will show you the demonstration video of this test. Concrete slump test. Slump test is the most commonly used method of measuring the consistency of a concrete work where the nominal maximum size of the aggregate does not exceed 38 millimeters. This method can be employed either in a laboratory or at the site. Operate is required for slump test is the mold for the test specimen is in the form of the frustum of cone having the bottom diameter of 20 cm, top diameter top centimeters, and height of the cone is 30 cm. A metal plate of thickness 1.6 mm is used as a base. A tapping rod of 16 mm diameter and 0.6 meter long is used. Let us now see the step-by-step procedure for concrete slump test. The internal surface of the mold should be thoroughly clean and free from the moisture of any set concrete before commencing the test. The mold is placed on the smooth metal plate. The mold is filled in 4 layers, each approximately 1/4 of the height of the mold. And then each layer should be pampered with 25 strokes with tamping rods such that the strokes are distributed over the cross-section. After the top layer is filled, the concrete is struck off level. Should be removed from the concrete by slowly raising in the vertical direction. Now you will notice concrete tends to subside. This subsidence is referred as a slump of concrete. This slump value is then measured by the difference of height of the mold and depth of the highest point of the specimen. This difference in hiding is taken as slump of concrete. The pattern of the slump is displayed on the screen, like through slump, shear slump, and collapse slump. The slump value and its acceptable usage are tabulated on the screen. That's all from me. Thank you.
Okay, now I will explain about the density test of concrete. The density test of concrete is a test used to determine how much mass of concrete is packed into a certain volume. Purpose of the density test is we want to check the quality of the concrete, compare with the design specification, and detect problem in the mix. Now I will show you video demonstrate a density test using a 0.250 feet cube measure and concrete with a slump greater than or equal to 1 inch. First of all, dampen measure and remove any standing water from bottom. Zero scale and record mass of empty measure. Fill the measure to approximately 1/3 of its volume. Rot the layer 25 times. Tap sides of measure 10 to 15 times with the mallet to close a void. Fill the measure to approximately 2/3 of its volume. Rot 25 times, penetrating previous layer by 1 inch. Tap size of measure 10 to 15 times with the mallet to close voids. Fill the measure slightly above rim. Roll 25 times, penetrating previous layer by 1 inch. Tap sides of measure 10 to 15 times with the mallet to close voids. Prior to strike off, add or remove concrete as need to achieve approximately 1/8 inch above rim. Cover 2/3 of the measure with the strike off plate. Pull plate back using a sewing motion. Cover 2/3 of the measure with the strike off plate. Push plate forward using a sewing motion until it slides off. Incline plate and use each to produce a smooth surface. Completely clean the exterior of the measure. Zero scale and determine the mass of the full measure. Lastly, report density to the nearest 0.1 pound-feet cube.
Hi everyone, today I want to share what is timber in civil engineering. Timber is derived from tree and is one of the oldest building material used in construction. It has been utilized for thousands of years due to its availability and versatility. Timber is lightweight, easy to handle, and has natural aesthetic appeal, making it popular choice in civil engineering. Engineers consider various wood species, each with its own unique characteristic when selecting timber for construction. Some timber types are more resistant to decay, while others provide greater strength or flexibility. The selection of timber species is important for the durability and safety of structure. Common applications for timber include beam, column, flooring, and roof system. Timber can withstand tension and compression, making it suitable for various structure elements. Preservative can be applied to timber to enhance its longevity and resistance to moisture and pests. Timber is recognized as an environmentally friendly building material due to its renewable nature. Suitable building practices have increased interest in timber as choice for eco-conscious projects. Timber structure can help reduce carbon footprint compared to concrete or steel alternative. Limitation of timber include susceptibility to fire and performance issues related to humidity and temperature change. Engineers must assess environmental factors when designing timber structure to ensure safety and longevity. The use of timber in construction reflects both traditional practice and modern innovation in building design. So, use timber in construction.
This video shows a standard test on a timber specimen of the grain. The type of test is a standard Euro test for timber classification. The timber used in the test is Gulam GL28. The loading diagram shows a compression force eventually applied to both ends of the specimen. Compression force are now being applied to the specimen. We can see the wood cells started to crush, where this stage developed and strain of the fiber creates near the middle of the specimen with large block of wood spreading to the side. Now, if we take an oblique look at the specimen, we can appreciate the lateral deformation accumulated as the fibers spin or roll over each other. This graph shows the displacement relationship in the specimen. When wood is stress compression perpendicular to the grain, the wheel cellulose don't offer much resistance to crushing and the behavior is highly nonlinear. The implement strength perpendicular to grain is difficult to measure precise given the concentration stress strain behavior to several wood under severe loading deformation. Wood under the severe loading deformation compress about 1/3 of its original. That was for me.
We'll talk about the lab test on timber. The lab test on timber is the moisture content test. On timber is a procedure to determine the amount of water present in the wood, expressed as a percentage of its oven dry weight. This is a critical measurement because moisture level affect the wood stability, strength, durability, and machining properties. With incorrect moisture content leading to issues like warping, cracking, or fungal decay. Common methods for moisture content testing. There is two primary methods are widely used in the industry. The first one is the oven drying method. It is direct measurement, and the electrical moisture meter method indirect measurement. Okay, for the first one, the oven drying method. It is a primary or a reference method that industry use. This is considered the most accurate and reliable method, often used as a standard for calibration or in cases of dispute. Okay, for the second one is electrical moisture meter method. It is practical and field method. Moisture meters are popular for quick on-site measurement in the field or workshop. Okay, so let's move on to the video that I've prepared about how to check moisture content on wood using electrical moisture meter. Okay, so this is the video that I'm going to show you about lab tests for timber. Okay, before applying coating to exterior wood, we want to make sure that the wood is dry. One way that we can do is to use a moisture meter and a moisture meter. It's a just testing tool that can determine whether the wood is moisture or not. Okay, so we just insert the probes into various areas of the woods in this particular area here. We're getting a reading of about 19% now. This moisture meter has graduated from 10% up to 28% moisture. It's also color coded from green to yellow to orange to red. We're in the darker orange range at 18% to 19%. So we were going to let this structure dry for another day. Come back and test it. We want to see a moisture level down around 15 to 16% or less. So that's will make construction building more efficiently and no termite can live there. Thank you.